In arithmetic ability, the topic is logarithms. So hi friends, in this topic first I'll explain you all the details, all the information from logarithms and some properties of logarithms. Also important formulas which are related to logarithms I'll explain. Then after completing every topic from logarithms, let us discuss one model paper. So I'll show practice paper here, how the questions will come in any examination point of view. So this paper and some other papers also available, I'll explain you. So before that, these all the papers you can find in this website. So you can see here, right, foundation for it.com. So if you log into this, all the model papers, not only logarithms, other topics materials is available for free of cost. Not only that, ICSE, CBSE, SSE in intermediate level 6th to 12th class, all the boards, all the subjects papers are available and including material. So this is a site website information. So just to go through the website and you can find out various informations completely for free. So there is a link in description below. Directly you can click on the link and you will redirect to the website. So you can see the plenty of model papers and PDF papers which you can download easily. Fine. Yeah. Now start the topic. Logarithms. First let me explain what is logarithm. So definition, if you see this, how we can define a logarithm. If a is any positive real number, any positive real number. So if you understand the definition clearly, then you can do example sums. At the same time properties also you can understand easily. If a is any positive real number other than 1, so except 1, any positive real number, a to the power m is equals to n. So we can take m is then, so is any positive real number, then a to the power m is equals to n. Then this is in exponential notation, a power m is equal to n. Then m is equals to, so this value whatever it can take, so a to the power m is equal to n. So for example write 2 power 3 is equal to 8. So and so we can take, right? Now log n to the base a power m is equal to n, then m is equal to log n to the base a. So let me explain in detail. This means m is a log. For example 10 to the power 2 is equals to 100. Okay, this is an exponential notation. 10 power 2 is equal to 100. So this we can convert into logarithmic form, that is log 100 to the base 10 is equals to 2. So here the easy to remember is, here is the base is 10, same base also 10. So this power only will be value of this. So log 100 to the base 10 is equals to 2. You can take in negatives. For example 2 to the power minus 3 is equals to 1 by 8, because 2 power minus 3 is 2, 1 by 2 power plus 3, so 1 by 8. Then this we can write log 1 by 8 to the base 2 is equals to minus 3. So logarithms are defined only for positive real numbers. That's the main important. It works only for positive real numbers. Even you can take in other letters. X to the power a is equals to y. Then now we can write log y to the base x is equals to a. So that power you can take, that should be equal to. So this is conversion from logarithmic form to exponential, and exponential to logarithmic form we can convert. So before doing the problems, let me explain all the properties in logarithms. So around 20 to 25 form properties are there. These are all very important, especially in examination point of view. You can do easily. First I'll explain you all the properties. Properties of logarithms. So we'll see in details one by one. First one is log a into b to the power x to the base x. Log a into b to the base x. So we can split this log a to the base x plus log b to the base x. So any multiplication we can divide with the plus symbol, like, so an example. Okay, every property I'll explain with example. Now log 16 to the base 2 is given. So 16 I can write 2 into 8 to the base 2. So we can separate this. That means log 2 to the base 2 plus log 8 to the base 2. So if it is multiplication, we can convert it as the plus. So anything you can make, not only a into b, any number. Like log a, b, c, so on to the base x. So you can write log a to the base x plus log b to the base x plus log c to the base x plus so on. Next, if it is division, log of a by b to the base x. So if it is multiplication, we are separated with plus. Now if it is division, we'll do subtraction. That is log a to the base x minus log b to the base x. This is the property. So some properties I'll tell you example, some directly can understand. Next property is log a to the power m to the base x. So that power you can write front m into log a to the base x. Okay, you can write an example. Log 3 power 2 to the base x. So we can write 2 into log 3 to the base x. Any power we can write as front. So there are proofs are there for these formulas. Properties is all not required now. Just remember the properties for examination point of view. Next, log a to the base x. So this we can write in this notation also. Log a, so to the base y into log y to the base x. So if you observe here, this y and here y is same. That's why you can take any other number, log a base y into log y base x. So we can write like this. Now log 3 to the base 2 is given. So we can write log 2 logs you can write. Here must be 3 and here should be 2. You can take any number x. In the place of x any number also you can take. So value is not changed. So these all the properties we'll use in problems. In terms of division, log y to the base x, then log a to the base x, or we can take log y. So the same base we can write. One second. Log y by log x, the same base. I'm taking some base is a, so we can write like this. In case the same formula with, if you want a base, now log a by log a, the y and x you can add xy. Yeah, this is the way. These are the another property. In power notation, one property I'll tell you: log x to the power y whole to the power m by n. Okay, this, as I said previous formula, power you can write front, m by n, log x to the power y. Okay, again this you can write m by n into y, because y is the power, so log x. Okay, this way you can write. Next, some cyclic order type of property: log a into log b into log c. So same ABC you should write your log a to the base b, log b to the base c, log c to the base a. So ABC is in cyclic order, so that values are 1. Anything is coming like this, the value will be 1. Next one, property in power notation. For example, a to the power log m to the base a, then that value also will be 1. Log a to the power log m to the base a. Still some more. Log m to the base a. Okay, explained previous. Now log of a into b by c. So first two formulas, log a into b and log a by b. So based on that, first division. So log a into b minus log c we can write. Again, because of a into b, plus log a plus log b and minus log c is as it is. So any base is given, that base you can apply. So base is fixed. For example, base is x. So every log we can use the same base. Same in terms of power notation. Log a to the power p and b to the power q. So first we will use a product rule. So means log a into b. That is log a to the power p plus log b to the power q. If you want to simplify more, p into log a plus q into log b. So powers you can write front before the log. Similarly, you can do one property in division also. So log a power p by b power q. So first step we are subtraction. That is log a power p minus log b power q. Then p into log a minus q into log b. Right? Then conditional properties I tell you. If and then type. If log m to the base a is equal to x. Then same log m to the base 1 by a is equals to minus x. Okay, this is the formula you can use in examination point of view. Here log m to the base a is equal to x, then log m to the base 1 by a. If you take 1 by a as the base, this will be minus x. Similarly, that is log 1 by m. So m becomes, if 1 by m to the base a is equals to same minus x. Both if you interchange, so reciprocal when you're doing, change the sign. Now log 1 by m to the base 1 by a is equals to again plus x. If you enter reciprocals of base and values, the sign will be not changed here. Two at a time if you do. One more in power property. A to the power log b to the base m is equals to b to the power log a to the base m. So this also one of the property will be equal. Next property is related to the cyclic order type. This will come in properties 1 by log a into b into c to the base a to the power n plus 1 by log a into b into c to the base b to the power n plus 1 by log a into b into c to the base c to the power n. So this value is equals to n. Okay, an example I'll write here. See example 1 by log abc some root a plus 1 by log abc square root of b 1 by log abc to the base square root of c. That value is 1 by 2 because root a is equals to root a, you can write a to the power 1 by 2. That's what the power here, a to the power n. So n value took value. Now here a root a, so a power 1 by 2, root means b power 1 by 2, root c power 1 by 2. So 1 by 2 is answer. Few more properties. Then one division property actually. For example, log x to the base a by log y to the base a minus log x to the base b by log y to the base b. Same base means that value will be 0. Let us see the property of one more. So these are the properties. If you remember, it's easy to understand the problems. I'll explain you after properties all the sums which will come for exam point of view. Next one, log of in the bracket again one more log. So log of log x to the power p minus log of log x to the power q is equals to log p by q. So this we can use property also. So a minus b, log a minus log b is log a by b, right? So log of a by b, that means log x power p by log x power q we can write. So this is log of x power p by log x power q is p by q. P by q into log x by log x. So we both are get cancelled. Then log p by q will come. Similarly, one more property which are like this. Log of log x to the power 1 by p minus log of log x to the power 1 by q, 1 by q, then that is log q by p, because reciprocal, so you'll get q by p. Then log some y to the power n base x to the power n. So this you can write m by n log, okay, this is m power second right front, m by n log y to the base x. Then a to the power log m to the base a. Now that is m. I said one formula little like this. So these are the main important properties we'll use in logarithms. Then if there is no base, so we can take 10 as the base in examination. If there is no base, then 10 is taken as base. So only if they said log 100, that means log 100 to the base 10. If they're not mentioned, you can take 10 as the base. Fine. Now there are two parts in logarithms. In logarithms there are two parts. The two parts are characteristic and mantis. Let me explain that. So there are two parts in logarithms, characteristic and mantis. So what is these two parts? Characteristic. The integral part of the logarithm is known as characteristic. Integral part. And mantissa is the decimal part in the logarithms of a number is known as the mantissa. So okay, example. For example, if we take log any value, for example log 348 value, or log 10, log 13, any value if we find out, in this integral point is there, some number point and decimals. So integral part is characteristic and decimal part you can take it as a mantissa. So you can see in the logarithmic table also. So if you using calculator, logarithm is log calculator, then integral part is a characteristic, Integral part means before point, then after point is decimal. This is the decimal part. So you can use the log calculator or logarithmic table for reference this mantis and integral part. So these are the important properties from logarithms. Now let us see the how questions will come from this topic logarithms in any examination point of view. Okay. Let us discuss this one model paper. Okay. So this paper, if you observe, so not only practice exercise 1, so there are some other papers also available. So for time being I'll explain you one paper, then other paper including solutions you can find out complete information in this website. So you can click on this and you redirect to that, you can learn from that for the remaining questions. Now whatever properties I explain, using the properties only will solve all these problems. First one, 9 to the power log 2 to the base 3. Okay, so what formula we can use? With example I'll tell you here. Question is 9 to the power log 2 to the base 3. Now what property can use in this? A to the power log m to the base a is equals to m. So this is the property. Now this formula type we have to convert the question. Then how we can make 9, I can write 3 square because your base is 3. 3 square log 2 to the base 3. Now again 3 to the power log 2 to the power 2. So this we can cover as this power because one more formula, log a to the power m. Log a to the power m is equals to m into log a, or vice versa. M into log a is equal to log a power m to the base 3. Now this is same. Then 3 to the power log 4 to the base 3. Therefore the answer is 3. So sorry, answer is 4 because this is the value. So two properties are applied in this. Now according to the question, number of properties we required, so we need to apply. Next, log 324 to the base 3 root 2. Question is log 324 to the base 3 root 2 is equal to dash. Log 324 to the base 3 root 2. See, so what are the properties we need to apply, that we should know first. Then it's easy. So log a to the power m to the base a is equals to m. Otherwise log a to the power m and a to the power n is equals to m by n. So power secant right front. These are all the properties. So value and base value, if you make it same, then you can take the powers. So 324 how can you write? We do prime factorization. 2 table, 2 ones are 2, 162, 80 ones are, and 3 table, 27, 3 nines are, 3 threes are. So finally 3 power 4 and 2 to the power 2. This is a 324 value. Next, 3 root 2. 3 into root 2. So that also we can change. Otherwise, 3 to the power 1 and 2 to the power 1 by 2. Now altogether I am making as question. See here. So log 324 to the base 3 root 2. So log 324 value 3 power 4 into 2 power 2 to the base 3 power 1 into 2 to the power 1 by 2. Now that value also is it possible to make? Now log 3 into, so 3 root 2 whole to the power 4 I can write, and this also 3 root 2, because 3 root 2 whole to the power 4, this only 3 into root 2 whole to the power 4, because root 2 whole to the power 4 is 2 power 2, because whatever base if we make that value then we can write it as the power, then that is the 4, because power 4. Fine. Next one more here given, 5 power a is equal to 0.5 power b is equal to 1000, then 1 by a minus 1 by b is dash. Let me solve here. So first given condition you let me write, 5 to the power a is equals to 0.5 to the power b is equals to 1000, right? Now what I have to find out, 1 by a minus 1 by b. 1 by a minus 1 by b is equal to dash. So first a value b value will find out separately. So 5 to the power a is equals to 1000, 0.5 to the power b is equals to 1000. So 5 to the power a is equals to 1000, I can write 10 to the power 3. 5 power a value. Then from this I want only 5 value. So 5 is equals to 10 to the power 3 by a. So all to the power 1 by a I did. So 5 is equals to 3 power 10 power 3 by a. Now this side 0.5 whole power b is equal to 10 power 3. Same. 0.5 whole power b. So whole power 1 by b both sides. So 0.5 is equal to 10 power 3 by b. So then I will do division both. Therefore 5 by 0.5, 10 to the power 3 by a by 10 to the power 3 by b. So 10 to the power 3 by a minus 3 by b. 5 by 0.5 is 10, because into 10 by 10. 5 by 0.5, remove the point means 10 by 10 multiply and divide. So 50 by 5, that is equal to 10. Now 10 is equals to 10 power 3 by a. 10 to the power 3 by a minus 3 by b. Here is 10 power 1. So when the bases are same, powers are equal. Therefore 1 is equals to 3 by a minus 3 by b. Take 3 common. 1 by a minus 1 by b is equals to 1. Then 1 by a, therefore 1 by 3 is equals to 1 by a minus 1 by b. So 1 by a minus 1 by b is equals to 1 by 3. So some problems will give like this. You need to find the value of separately. 1 by 3. Next, a power x is equal to b power y is equal to c power z and x y z are in GB. So geometric progression. So these problems all I'll explain in progressions topic separately. If you understood the progressions, then you can understand this easily. So you can see in the progressions topic this question. Let me see fifth one. This you can see in progressions topic. If log 4 into log 3 x is equals to 1 by 2, then x is equal to dash. Fifth one. So let me write question first. Log of log x to the base 3 is equals to 1 by 2. So this value, if you make it log x to the base 3 is equals to 4 to the power 1 by 2. So 4 to the power 1 by 2 is 2 square power 1 by 2, 2 to get cancelled, that is 2. Log x to the base 3 is equals to 2, then x is equals to 3 power 2. So 3 power 2 is equals to 9. So properties I am applying here, nothing more. Sixth one, this you can write in 1 by 1000 and 1 by 1000 notation, you can understand easily. 0 point after point 3 zeros, 3 zeros. Actually this is 0.00. One more 0 is there. So 10 to the power minus 4 and this 10 to the power minus 3. Then you can get log n between this and this. Now some are direct formulas. Log of a to the power log m to the base a plus log n to the base a. So m into n. So a to the power log m into n to the base a. So m into n is the answer. Next characteristic I said, right? So eighth one, log 2 is equal to 0.3010. Then what is its characteristic? So characteristic means the integral part, mantissa is the decimal part. So characteristic is before point. This is characteristic. And 3 point, this is mantissa. No, they're asking only characteristics. So 0. Characteristic means integral part. And mantissa is the decimal part. So 0 is the characteristic. 0.3010 is the mantissa. Ninth one, log 49 to the base 343. So like these questions we should make a property, that is 49 I can write 7 square, 343 I can write 7 cube. Now this is 2 by 3 because powers, the property. So you remember property, right? That is log a to the power m a to the power n is equals to m by n. So 2 by 3. 10th one, log root a to the base a plus log a square to the base a. Let me take the board. So this 10th sum, log square root of a to the base a plus log a square to the base a. So property I am applying. First property is log root a is a power 1 by 2 to the base a plus log a square to the base a. So log a and base a are same. So this is 1 by 2 plus this is 2. So 1 plus 2, 1 by 2 plus 2 is 5 by 2. You can do LCM. 5 by 2 is the value. Yes. So properties only I am applying here. Similarly, this also log of log x power 9 minus log of log x power 3. So log of p by q formula, this power 3. Log of p by q. I said one property, right? So 9 by 3 means 3. Log 3 will come. If a is equal to log 0.001 to the base 0.1, b is equal to this, then root of a minus 2 root b is dash. Let me take the board and solve. This is 12th sum. 11th is just apply the formula. A value is given, b value is given. A is equals to log 0.001 to the base 0.1 and b is equals to log 81 to the base 9. Okay, then you can find out, we should make the base same. Log 0.1 whole cube, I can write this, because 0.1 whole cube is 0.001 to the base 0.1. Now that is 3. B is equals to log 81 is 9 square to the base 9. So B is equals to 2. Now what condition they ask? Find out square root of a minus 2 root b. Therefore square root of a is 3 minus 2 root 2. In the place of a, b values you can simplify. 3 minus 2 root 2. So we can still need to simplify more. 3 minus 2 root 2 under square root. 3 minus 2 root 2 is, that is root 2 minus 1 whole square. Because according to option you can see which one will come. Root 2 minus 1 whole square is 3 minus 2 root 2. Square and root get cancelled. Root 2 minus 1. And here some are properties directly. Log y to the base x is equal to z. Log y to the base 1 by x is equal to minus z. Right? Just apply the formula. I mean properties only we need to apply here. 14th, log 2 plus 1 by 2 log x plus 1 by 2 log y is equal to log of x plus y. Then which is the condition is true in this? So condition is log 2 plus 1 by 2 log x plus 1 by 2 log y. is equals to log of x plus y. So we can make the log both sides. This how we can write log 2 as this log x to the power 1 by 2, because m into log a is equal to log a to the power m, plus log y to the power 1 by 2 log x plus y log of 2 into, so log a plus log b plus log c is log a into b into c, right? So 2 into x power 1 by 2 is root x into root y is equal to log x plus y. So remove the log both sides. 2 into root of xy is equals to x plus y. Then squaring on both sides. Squaring on both sides, if you do, then what will come? Whole square on both sides. X plus y 2 of root xy whole square is equal to x plus y whole square. So apply the formula. This is 4xy x square plus y square plus 2xy x square plus y square plus 2xy minus 4xy. So x square plus y square minus 2xy. This you can write x minus y whole square. X minus y whole square. X minus y whole square equal to 0 means x minus y is equal to 0. So x is equal to y. Fine. So this is the condition. X is equals to y. Yeah. Next problems are using the properties only. If a is equal to 27, b is equal to log 4 base 3, then a power b, a to the power b. A is 27, b is log 4 base 3. So a is equals to is given. What is, yeah, a is 27, b is equals to log 4 base 3. Now they are asking find the a power b. So 27 to the power log 4 to the base 3. So 27 I can write 3 cube, because here base 3, no, you need to same power 4 3. So 3 to the power log 4 cube to the base 3, that is equals to 4 power 3. Then 4 power 3 is 4 into 4 into 4, 64. Yes. Log, next one, log 128 base 8. So 128 and 8, we should write some 2 to the power, easily can get. This I can write log 8, we can write 2 cube. 128 is, so 128 factorization, 64, 32, 16, 2 8s, 2 4s, 2 2s, 2 1s. Finally 1 2 3 4 5 6 7. So 2 power 7. Then according to property 7 by 3 log 2 base 2. So most of the questions will use the properties only. So we need to do calculation. 17 is given. Log of log 5 to the base 25 to the base 2. So this also same one continuation property is there, no? Based on that you can solve this. 17 you get -1 answer. Same continuation property can solve. Let me explain this 18th also. So that is a long continuation process, like 7, question is 7 into log 16 by 15 to the base 2, to the base 2, plus 5 into log 25 by 24 to the base 2, plus 3 into log 81 by 80 to the base 2 is given. Now to simplify this, we'll use log a plus log b plus log c formula. That is log a into b into c. Before that, powers you can write log 16 by 15 all to the power 7 to the base 2, log 25 by 24 to the power 5 to the base 2, log 81 by 80 to the power 3 to the base 2. Now with single base 2 you can write all these values. Before that you can simplify everything. 16 to the power, that is 16 by 15 all power 7 into 25 by 24 all to the power 5 into 81 by 80 all power 3. So in these cases, if you prime factorization and make the simple powers, easily can cancel. Log to the base 2. Now we observe here 16 to the power 7. So 16 I can write 2 to the power 4. So 2 power 4 all power 7 is 2 power 28. 15 we can write 3 5s. So 3 power 7 into 5 power 7. 25 is 5 square. So 5 square all power 5 is 5 power 10. 24 is again 2 power 3 into 3. Because 8 3s all to the power 5. Similarly 81, that is 3 to the power 4, 4 3s are 12, again 18, so 2 power 12 into 5 power 3. So everything if we cancel, you get only 2 to the base 2. So log 2 beta the base 2 is 1. So simplification is required here, so we can simplify all to the power 5. Overall if we simplify, you'll get the same answer. So similarly we can use other properties also in this, not only 1920. This is 2 log cos theta plus log 1 plus tan square theta. 20 sum, you see. So 2 we can write as cos square. So into it is, therefore cos square theta. So log a plus log b is log a into b. Cos square theta into 1 plus tan square theta. Cos square theta 1 plus tan square is x square. Cos square into sec square is equal to 1. So trigonometry terms also we can use in this. Similarly this also same. You should make the base same. Okay, one more sum I'll tell you. This 21 log a to the base 2 log a to the base 4 log a to the base 8. Then how can you write log a to the base 2 log a to the base 2 to the power 2 log a to the base 2 power 3, we can write this. So log a to the base 2 plus this 1 by 2 log a to the base 2 plus 1 by 3 log a to the base 2, because 2 power 3 as formula. Then this overall if you can take the sum, Altogether you can take, if you take log a to the base 2 common, 1 plus 1 by 2 plus 1 by 3 log a to the base 2, so that is 11 by 2, so 11 by 6, 6 is LCM. So here is 1, 1 by 2, 1 by 3 are 2 common, 6 plus, so 11 by 6 log a to the base 2. Then a is equals to what value if it becomes 0? Log 1 is equal to 0. So log a is equal to 2 then, because 11 by 6 they said. If a is equals to 2, then log 2 to the base 2 is 1. 22nd also one of the property I explained. 3 power log 7 to the base 5 minus 7 to the power log 3 to the base 5. So we know that a to the power log b to the base c, you can take any one, is equals to b to the power same log a to the base c, then that value is equal to 0. Both are same. And log x to the base y is equal to z is defined only when z is positive integer and y is not a value, z is any number, all the above. So all of them, right? Because y power x is equal to z. Z is positive integer. Y is not a value. So y is just base. Z is any number. Z may be any number. Only z should be positive number. All the above. Any positive integer. So characteristic of log 10 to the base 10 point 0.002376. So one formula I'll tell you here. If you want characteristics of particular value, so decimals value. So after point, if there are n zeros after decimal, so there are 2 zeros. If n zeros, then n plus 1 bar. That's the answer. So 2 plus 3, 2 plus 1, 3 bar. This is the characteristics. If there are n zeros after the decimal point, the characteristic is n plus 1. Okay, number of zeros you should take always after point to find out the characteristic. Log x plus 1 to the base 3, log x plus 3 to the base 3 is equal to 1. So this also make it simple. Common log 3 x plus 1 x plus 3 is equal to 1. So 1 we can write log 3 to the base 3. Then you can factorize. Then x plus 1 into x plus 3 is equal to 3. So if you factorize, you will get this. If you factorize, x square plus 4x is equal to 0 will come. If you take x common, x plus 4 is equal to 0. So x is equal to 0 or minus 4. So 0 you can take. Fine. So practice exercise 2. Some exercise 2 also I just kept here. Now not only these two, some other papers also available in this website from these logarithms. So you can directly download and you can see the solutions which are given links in the description below. So most important is we should perfect about the properties of the logarithms. Fine. So I hope you understood well, and please subscribe this channel because this is channel is only educational videos only we'll do upload, and if you subscribe you can get the information directly to your mail. So I hope you understood well, and thank you for watching this video. Have a nice day. Bye bye.